Hi everyone, in this video tutorial we will learn the basics of Abaqus using or through Tensile Test using Abaqus. First of all, we need to create our part of specimen for testing simulation. First, we need to create parts in Part module. Click on Create Part icon, name the part and take a name as specimen. Name the part. We select the modeling space, 3D or 2D planar or axisymmetric. In our part we need to use 3D dimension. Type of our part, deformable part, discrete, rigid, analytical, rigid or Eulerian. We need to use deformable parts. And shape, solid shape option, we need to use solid, shell, wire or point. We need to use solid and extrusion type. We can also use revolution and or sweep. In our part we need to use extrusion, solid, and in this part, in this option, we need to use the size of our zone of sketching and click continue. We see in this side many options to create our sketching for our part. We have points, lines, circles, rectangle and more options in this side. Let's start with creating a line of our specimen. Let's start with creating sketch of our specimen. We need to draw the quarter parts and use option of symmetrical option with mirror line. Let's see what we need to do. First, line, create line and click on the first point. We can click on the point or enter their coordinate system in XY value. We use click there and we can see in the top corner the actual coordinate of our cursor. This is our actual coordinate of our cursor and point. Click there and go side and click in point where we need to stop and go in the next point. Click there, yes, we have this option, have this sketch, and we need to take some dimensions in for our specimen. As we say before, we draw the quarter of our part. We're drawing the quarter of our part and use option of symmetry to drawing the all parts. Click on this option to take dimensions and click in the part, click in the line and add dimensions. We add 50 millimeters and click enter. The second part, the second option, the top side 10 millimeter and this side 20 millimeter, and we can use this option to remove line. Trim option, this option, remove these two line. We have 5 millimeter in this. We don't need dimension there, and click create line in this side with length with 20 millimeter, and create split line between these 2 points. First we have split line, or create arc, or the use arc tangent, or any others option there, or create corner with this option. Radius option need radius of corner. Click enter and select the first line and the second line, but this option can't we have error message. A fillet cannot be created with the given radius between two given entities. This error message between these two lines, we have an error. Let's this fillet curve, and let's use this option. Or we need to remove this line and draw another line there. And create radius between this one with with this wrong value. Create is equal to 5. Click enter and select first line, second line. We also have error message. Let's go another option. Remove this line and no. Let's use this option of create ellipse to create ellipse in this part, and click in this point and select the second point and third point. We have an ellipse, and create line between this point and this, and we need to use trim option to remove this part. We have the quarter part. We have the quarter of our sketch. Use the option of construction line to convert this line to construction line, and select the line, the first line, and click done. And we need also select the second line in the bottom and click done. We have our first sketch. We can save this sketch in our module and click in save sketch. Let's add a name for this sketch 1. Take it as it, and we need to use option of mirror. Select the type of mirror operation. Copy and pick the mirror line. Select the first one and click done. Select the entity, and when you select the entity to mirror, then select all. Yes, we have now we have the half of our specimen. Another step, we need to use also the same option, mirror option, to select the entity to mirror. Now click there and click mirror, copy, pick the mirror line, this bottom line this time, click done. And now we need to select the entities to mirror. Select wall parts, wall sketch, click done. Now we have the wall sketch of our part of specimen, or wall sketch of our specimen, and we done to this part. Now click done and sketch the section for the solid extrusion. Click done. Now we need to add the depth or thicknesses of our specimen. Let's use 4 mm and click OK. Now we have our specimen for tensile test. Now we have the wall part of our specimen. In this step we need to add or need to partitioning these parts for simplify the meshing and simplify the type of mesh and geometry of mesh. And we need to add for this reason, for meshing reason, we should to partitioning these parts. We have many options to make partition of this part. We can use many options. Create part. We have use edges, faces, or cells. What we need to, where we need to create partition. Let's create some datum plans first. Create datum. First we need to create XZ datum, XZ plan, and add the value of offset from the 0 value. And also we have many options to create offset. Let's take a look at another option. First, create datum plan with 3 points. Click on it, select 3 points to create datum plan. First one, second one, third one. That's it. This is first plan and second plan. We need to create partition in these parts, in this point. First point, second point, third point, the second plan. And now in the bottom of our specimen, first point, second point, third point, we have another plan. Another time, first point, second point, third point, and we have another plan also. In this part, in this time, we need to add some partition in this zone there, for add some features in the future option, or we need to create sets in this zone and these to add more options in our specimen. Let's create another datum plan. Select the first point in the datum plan, first point. Select the second point in the datum plane, second point. Select the third point in the datum plane, third point. That's it. We have the plan in this point. Let's add another datum plan. First point, second point, and third point. Now we need to create partition of our specimen. Click create partition. What we need to partitioning in this time? We need to partitioning cell. Which tool we need to use to make partition in this cell? We need to use datum plan, and in the message select the datum plan. The first one is this. Partition definition completed. Create partition. We have one partition and two cells. The first one, second one. and now we need to create another partition. Select the cells to partition. Select these cell, click done, and select dot on plan to create cell, create partition, and that's it. It's very easy. The first cell, second cell, third cell. Select the cells to partition. Click done, select dot on plan, create partition. Another time, select the cell, click on, select dot on plan, create partition. Select cell, click on, select dot on plan, create partition. Select cell, click on, select dot on plan, create partition. And that's all in this option there. We make these partition for many reasons. The first and important reason is to simplify the mesh for these specimens. In this image, we represent many parts of our specimens. We have clamping area and gauge length, and gauge width, reduced section, and all specimen length, and distance between shoulders. All these options we take it in our specimen of Abaqus. We have clamping area represented in these cells, in these top cells and these bottom cells, and gauge length represented by these two partitionings when we need to create two sets in this zone. The first one, the first gauge, and the second one, the second gauge, to simulate the displacement of these two gauges. And now the second part, we need to go to the property part of our CA program. Now we have many options in this module. First, take it easy and create our material. Take and add name of our material. Let's take steel material. We can add some definition, material behavior. We select in this time we need to use, or we simplify the work by using elastic property of our material. Elastic, add Young modulus to our material. In these cases we need to add Young modulus of our material. In this simulation we need to use steel material with Young modulus with megapascal units. Because we have millimeter in our dimensions, we need to use megapascal in the constraint and others, and 0.3 in buoyancy ratio, and click OK. And the second option, we need to create section. Name it the section, steel section, solid, homogeneous, and continue, and select the material. We have just one material, it's default selected, and click OK. And now we need to add the material and the section created before in these parts. Click assign section, select the region to be assigned section, create set if you need. No, we don't need this option now, and select the whole part of our specimen and click done, and select steel section, click OK. Now we have the default property, it's green. It's green, that means we don't any error on any warning in this material, and click done. That's all for this module of property. Now let's go to assembly module and click assembly, and now we need to add the part in our assembly. Click create instance, select the part specimen and apply, and click OK. Now cancel. We have these specimen in our assembly. That's all for this module now, and before we have one part, we don't need any other options. Now we go to the step option. It's a very important part in our simulation. In this part we need to select which type we need to simulate, in static analysis or dynamic analysis. We simplify the test and the simulation by using static analysis, selecting static general step 1. We can name it static test, add the name and continue. We need to add some options there, and because we have elastic property without any plasticity or any damage, we don't need to add any other options in this part, and click OK. Now we go to interaction option. In this part we need some property, some interaction, but in our simulation, this simulation, we have just one part. We don't need any interaction between other part. I think we should escape this option now, and go to load option, and go to load modules. Now we need to add some limit condition in our part, and add a load in our specimen. Now we need to add limited movement in the bottom cells there. Click create boundary condition, name it the limit condition BC1 static test, select the step, category of our load, type of selected step, symmetry and symmetry in cluster. Click. In this part we need to use cluster. Click continue, select these parts in the bottom. Let's take a look at in this option, select cells. In this part now we need to select these bottom cells by add cells there. Select done and uncluster. Uncluster, that means the limited movement in all directions and limited rotation in all directions, and click select and click OK. We have uncluster in the bottom part. Now we need to add limited movement but free movement in this direction, Y direction. Click correct boundary condition, BC2 symmetry anti-symmetry, or need to use displacement rotation. Continue, select the bottom, the top cells, the top cell of our specimen. Click done. Now we need to select limited movement in all direction, just this Y direction. We need to make free to move in this direction. Click OK. Now we have these two options. We can to move left by inserting in the initial step and go on. Now we need to add the load in these specimens. The load in our simulation is the displacement in the y direction and after creating displacement we can extract the reaction force of our specimen. Now we need to go create boundary condition, displacement rotation, click continue and select the top cells of our specimen. In this direction select and click, and now we need to add the displacement we need. Let's add 25 millimeters and click OK. Now we have these directions of load of our load. Now when we have a wrong direction, for example edit, let's add -25, click OK. Now these load represent the direction of our load. We don't have the compression test, we have traction or tension test. We need to reverse the sign of our load. Let's add 25 millimeters and click OK. Now we have all necessary loads and conditions of our specimens for this simple tests of this simulation. Now let's go to mesh module, and now we need to add meshing in our parts. We have many options. The first option, seed of parts that represent the type and represent the size of our mesh. We have an erroneous dependent part instance, dismiss and click in this option there. Now click global seeds. We need to add the seeds of our, or the size of our elements. Click to apply, select apply. We have these options. We have this partition. Click OK. In this option, now assign mesh control. In this option we can control the type of our the type of mesh of our specimen. We can select hexadecimal, hexa or hexadominate, tetrahedral or widget. We have structural, sweep and bottom up. Now all things are great and green, that means all things is great. Let's take it as it and click OK. OK. And meshing part, click meshing part and click yes. Now we have this mesh of our specimen. We can add more refinement of our mesh by minimizing the seed size. Click 1, apply. We need to delete the previous mesh. OK, OK, and meshing the part. Yes. Now we have this part, this mesh of our part. Now we need to go. The final step is to create our job for simulating our test. Create job name, test, continue, and in this we have many options to create the job. We have submission, general, memory, parallelization. We can select our processors we have, precision and so on. Click OK because we have sample test. OK, and we need to running the simulation. First we need to make data check for analyzing if we have any errors or any warning. We don't go to the simulation before checking the process. Now we have check completed without any errors or warning. Go to continue the simulation and continue the processing of our model. Continue. Okay. Submitted. Running, and we need to wait until the process completed. Now we have completed analysis. Let's go to result and show our result of our simulation. We have many options to show our result and of our simulation. We have this plot and deformed shape. Deformed shape, we plot the deformed shape and make the movement. And now we need to, now in this option we show the principal goals of our simulation. Need to show in this option we show the constraint, the different type of constraint we needed, and we show deformation and the deformation in all direction, reaction force, stresses in all direction. We have Mises, stresses, Mises criteria, max principle, absolute, mean, tosca, pressure, third invariant, and all stress in all directions. And also we have displacement in all directions. Displacement, the magnitude of displacement is in y direction, in x direction, in y direction, and displacement in z direction. I think that's all for this part. It's a very simple test, very simple simulation. I think you can take, or you can get some principal tools of the Abaqus software we needed in your simulation. In future video we need to add some option as the failure of this specimen, and add elastoplastic analysis, failure analysis using maximum strain and or XFAM method. And we need to very easy to use this software in many area of mechanics. Don't forget to subscribe and make likes for this video. See you soon. Thank you.